How do you build the world's longest bridge over the strait that sank empires? 2,023 meters of suspended steel, longer than any suspension bridge ever built before. This is how they pulled off the greatest suspension bridge engineering feat in history. Every single day, 45,000 trucks waited hours just to cross this 1,900-meter strait. Without a crossing, freight took 6 extra hours detoured through Istanbul every single time. Turkey built 2 Bosphorus bridges, both maxed out. The Dardanelles still had nothing. In 2017, Turkey signed the contract. Construction would begin within 12 months from here. Here's the crazy part. The first deck design failed catastrophically inside the wind tunnel. Tacoma Narrows collapsed from wind resonance in 1940. That failure lived inside every calculation. The fix. A streamlined box girder aerodynamically kills flutter at 250 kilometers per hour. But there was one massive problem. An earthquake fault runs directly underneath. The solution: seismic isolation bearings that let the towers shift and absorb earthquake energy. 318-meter towers, taller than the Eiffel Tower, built composite steel inside concrete walls. Each main cable holds 22,736 wires, enough to circle the Earth once over. Design finalized, 4,608 meters total length, $2.5 billion, 4.5 years to build. The biggest cranes in Turkey came by sea. No road could carry them here. 14,000 tons of high tensile steel delivered in month 1, just for foundation rebar. 50,000 ships per year cross here. Everyone detoured around the construction zone. 4-knot current runs here constantly. Divers fought it round the clock for mapping. Survey revealed 14 meters of soft sediment. The foundation design changed overnight. That's when they made a crazy decision: drill 43 meters through soft seabed. The caisson is 68 meters wide, an entire city block footprint welded from steel. Watch closely, a jack-up barge becomes a rigid offshore platform in open water here. 14,000 tons of steel floating to the Dardanelles, heavier than an aircraft carrier. This single miscalculation would ruin everything. Placement accuracy required within 50 millimeters. Valves open. 14,000 tons begin sinking. Nobody can touch it on the way down. It landed 38 millimeters off target, the best placement ever recorded at this scale. You won't believe how they fixed this. Grout injected at 200 bar seals everything. While Team 1 sank the Asian caisson, Team 2 was already working on Europe's. Now you might be thinking, how do you work inside a seabed steel box? 68 hours of continuous concrete pour. Cooling pipes prevent the heat from cracking. The climbing formwork is self-powered. It grips the concrete it poured, then climbs. Concrete pumped 100 meters vertically. The pump runs at 80 cubic meters per hour. But there was one massive problem. Solar heat pushed the tower 47 millimeters off plumb. The fix: deliberately tilt the next 3 pours opposite, laser-guided back to perfect plumb. Here's the crazy part. 4 steel tubes run the full height of each tower. Steel takes tension. Concrete takes compression. Together, they're 40% stronger than either alone. 90 kilometers per hour, winds halted all work. Storms cost 47 days across the entire build. While the storm raged outside, engineers tested concrete cores inside. 0 construction days wasted. At 250 meters, they cleared the Eiffel Tower. 68 meters still left to pour. Then, a magnitude 5.3 earthquake struck at 2 a.m. Workers 180 meters up. Morning inspection, 0 cracks, 0 deformation. The seismic isolation system absorbed everything perfectly. The saddle weighs 180 tons, placed at 318 meters within 5 millimeters of target. This is where it gets interesting. Saddle landed within 3 millimeters at 318 meters. Both towers done at 318 meters. Now hang 22,000 wires across 2 kilometers. 105,000 cubic meters of concrete poured upward, 42 Olympic pools stacked into the sky. They fired a pilot rope 2 kilometers across open water. Everything started from that. Workers walked mesh panels 70 meters above open water, assembling the catwalk mid-air. Wait until you hear this. The catwalk sways 2 meters. Workers walk it daily. Night shift 70 meters above the strait in darkness. Catwalk inspections never skipped. To understand this, look at the anchorage. 60 meters deep, blasted into bedrock. 400,000 tons of concrete, resisting 145,000 tons of cable pull. 22,736 individual wire anchors. 125,000 cubic meters in 30 stages over 7 months. One layer fully cured first. The anchorage block, buried, invisible, the size of a 10-story building inside bedrock. This 1.2-meter spinning wheel must cross the strait 11,368 times to complete one cable. Watch closely. 5.35mm wire, 1,670 megapascal tensile strength, each meter bearing 14 tons. 14 months of spinning. 22,736 wires crossed the Dardanelles strand by strand. But there was one massive problem. 12 wires showed surface corrosion at day 45. You won't believe how they fixed this. 12 corroded wires extracted and replaced individually. 3,200 bar of hydraulic pressure, compressing 22,736 loose wires into one solid 900mm cable. The cable wrapped 50% overlapping, sealing out salt air that would corrode wires inside. This is where it gets interesting. Dry air pumped through the cables 24 hours, both cables complete, 120 meters of designed sag under exactly 50,000 tons of tension. Cable tension equalized within 30 tons. Asymmetric tension would twist the deck once installed. Unequal cable tension twists the deck. That 30-ton tolerance separates safe from catastrophic. 200 cable bands clamped at exact intervals. Each one anchors a vertical hanger cable. Hangers installed from the exact center outward. Symmetry keeps the cable balanced throughout. Each hanger pin proof-loaded to 150% capacity before it ever touches the bridge deck. Every bolt torqued to exactly 2,800 Newton meters. Under torque drops the deck. Over torque cracks. Wait until you hear this. Every crane lift needed maritime clearance between passing ships. 131 ships per day. Every lift timed around them. They never stopped one ship. The deck sections were built 9,000 kilometers away in South Korea, then shipped here. The ship crosses the Suez Canal. 28 days sailing before the deck section arrives. 28 days at sea. It must land within 10 millimeters of the target. Exactly. 12 millimeters thick steel, 8 meters wide, 60 meters long. Flatness certified within 3 millimeters. But there was one massive problem. Deck Section 1 arrived 23 millimeters out of tolerance. A Korean welding team flew in overnight. They remachined the flange connections on site. Pins slide home at mid-span. First section locked 70 meters above the Dardanelles. Done. 2 deck sections per week at peak, both sides growing simultaneously from the middle. A section hung from the crane overnight. Operator held position through 70 kilometers per hour winds. Every new section sinks the cable 18 millimeters. The model predicted exactly 18 millimeters. The side spans differ, sitting on bearings, not hangers, twice as heavy per section. 12 millimeters off vertically at closure. Tiny over 2,023 meters, but absolutely critical here. 14 hanger cables, detensioned fractionally. Laser survey confirming alignment was checked every hour. The closure section is 2 millimeters short. Steel expands in heat. That gap is engineered. Both pins driven simultaneously. At that moment, the two halves became one complete bridge. Closure weld ran 22 hours non-stop. Hydrogen cracking at this joint would be catastrophic. Laser survey confirms 2,023 meters of deck within 6 millimeters of design. Extraordinary result. Normal asphalt fails on flexible steel. This polymer epoxy surface bonds and flexes without cracking. The deck breathes 3.2 meters annually. The joints must absorb that for 100 years. A 300-ton pendulum inside the tower top swings opposite to the sway, killing vibration instantly. 2016 sensors everywhere. Engineers in Istanbul see the bridge's stress levels every second. This robot crawls 2,900 meters of cable, scanning every centimeter without workers at height. 6 lanes, crash-tested barriers, emergency walkways, deck surface dressed and ready for load testing. 104 trucks, 4,160 tons total, 110% of design load, deliberately overloading the bridge first. Predicted 1.84 meters. Measured 1.83 meters. 1 centimeter error over 2,023 meters of structure. Every truck off, deck returns to zero. No permanent deformation from 4,160 tons total. Natural frequency confirmed at 0.102 Hz. Dardanelles wind cannot resonate this bridge, ever. Tower pushed 150 millimeters sideways, then released. Returns to vertical in 4.2 seconds. Model confirmed. First lights on, 1,200 LEDs illuminate the cables in Turkish red and white. 1,847 inspection points checked by an independent panel. 0 deficiencies found. Completion certificate signed. Last Construction Act. Catwalk dismantled. The bridge stands alone for the first time. March 18, 2022. The Gallipoli anniversary chosen deliberately. The bridge opens at sunrise exactly. Presidential convoy crosses first, named 1915 for the Gallipoli battle that defined Turkey. 210,000 vehicles in 7 days. The ferry's best day replaced in 24 hours flat. Logistics costs dropped 68% on day one. $1.3 billion saved every year. 340 hectares of industry appeared on the Asian shore within 18 months of bridge opening. The biggest secret nobody mentions. The lower deck waits for a future railway. If that rail opens, Istanbul to Izmir by train takes under 3 hours via here. 2 years of operation, 0 cracks, 0 fatigue, 0 cable degradation, every sensor green. Guinness confirmed, 2,023 meters, world's longest suspension bridge main span. Officially, permanently recorded. 32 meters longer than Akashi Kaikyo. That is the margin over the previous record. Designed to 2,122. Every system chosen to operate without replacement for 100 years minimum. Annual dive inspection. The caisson foundations are immaculate after 2 years underwater. No change. 4.5 years. $2.5 billion. The strait that stopped armies, finally bridged. The strait that sank empires now carries 30,000 vehicles daily. Nobody thought possible.